Okay, it's Sunday morning, the day before your final, and we're going to try and do POD number 6. I accidentally made 6 and 7 the same topic, but more practice won't hurt. So let's jump right into this. Rational functions. Rational functions are their own beast. And you learn about them in Math 100, but no one puts as much attention on them as I do, because I know you're going to use them in Calc 1 and 2, and so it's good to get your head wrapped around this. All right, so A. R sub x is x squared minus 1 over x plus 2. All right, so what do we need to find? We need to find the vertical asymptote, and that's where the denominator equals 0. So it's this. There's no horizontal asymptote because the degree on top is 2 and the degree on the bottom is 1, and 2 is bigger than 1. So that says we have a slant asymptote. We'll find that in a second. We want to find the y-intercept, and that's of course where x is equal to 0, and so y is going to be minus a half, right? Because you plug in 0 to the function, so r of 0 is minus 1 over 2. So there's your y-intercept. And then zeros in this case is where the numerator equals 0. So x squared minus 1 equals 0. Says x equals plus or minus 1. So you have the points plus or minus 1, comma 0. And to find the slant asymptote, you have to divide bottom into top. So we divide x plus 2 into x squared minus 1. So this goes x times, so I have x squared plus 2x, so subtract this. And so I bring down the negative 2x, minus 1, so x minus 2. And so you can stop here, because you got the line, so y equals x minus 2. Okay, let's go look here what we're supposed to find. Oh, I cut it off in the picture. There's no removable discontinuities. We found the zeros, y-intercept. We need maxes and mins. Okay, let's find the maxes and mins. R prime of x is what? Low d high minus high d low all over low squared, right? X squared, so low d high minus high d low over low squared. Okay, so we have now 2x squared plus 4x minus x squared plus 1 all over x plus 2 squared, and this becomes x squared plus 4x plus 1 over x plus 2 squared. I don't think that the numerator b squared. So the discriminant of the numerator is negative, so there's no solution. So just to be clear, when you're doing the the discriminant is, and in this case that's 60. Oh no, it does work. Darn it. Crap, we gotta find this thing. So we take x squared plus 4x plus 1 and set it equal to 0. And you complete the square. Half of 4 is 2. 2 squared is 4, so you add 4 to both sides. And so it's x plus 2 squared equals 3, which says x equals negative 2 plus or minus root 3. Okay. Okay, now we make a sign chart. And because minus 2 minus root 3 minus 2 plus root 3, because this thing doesn't factor very prettily, I'm just going to do a old school sign chart. Right? And it goes positive, negative, positive, I think. So max, min, there and there. And the beauty of these problems is, well, we can adjust later. So let's graph this thing. Oh, minus 4. Okay, let's see here. X equals minus 2 is a vertical asymptote, like that. What's the slant asymptote? Y equals x minus 2. Let's do this here like this. So it's got a y-intercept of minus 2 and slope of 1. So that's what it looks like. Those are our asymptotes. We got zeros, y-intercept at minus a half, zeros at 1 and 0. Okay. Y-intercept at minus a half. Y-intercept at minus a half. So y-intercept is here. And 0 is at 1 and minus 1. And so there's the right-hand guy there, and I'm guessing there is our, there is a minimum. And that does match. That does match the graph there. Or sorry, so you see this guy's going up, and so is this. And this guy's coming down from above, like that. So that's our minimum. This is the minimum, minus 2 plus root 3. And so on the flip of that, we have this guy here. And this is where the max is at minus 2 minus root 3. And so sure enough, the function is increasing along here, decreasing along here and here, and then increasing along there. So perfect. The ones with the slant asymptotes are always the hardest, but I like to pick them because they have maxes and mins. And now, I hope you all watch this before you take the final. I think up here I noticed that whoever your teacher is asked you to find the intervals of concavity. That would involve taking this derivative here, again, which is ugly and very prone to mistakes. So let's be clever about this. Look at this graph. It's concave down on minus infinity to minus 2 minus root 3. And it's concave up on No. It's concave down. Look at the picture, Brent. It's concave down on minus infinity to minus 2 and concave up on minus 2 to infinity, right? No computation needed. All right, that's A. Let's do B. X squared minus x minus 2 over x squared minus 1. Okay, well, this looks fun. We got to factor the top here. Is that right? No, it's x squared. I didn't do 2. X squared minus 1, not x minus 1. Okay, so first of all, right away you see one thing's for sure. These cancel. But that says what? That says there's a removable discontinuity at the point minus 1 comma r of minus 1, which is what? Minus 1 minus 2 over minus 1 minus 1. I just plugged it in here, which is minus 1 comma 3/2. So that's important. And now all we have to do is graph this guy and remember to put a hole at negative 1 3/2. So vertical asymptote at 1, horizontal asymptote at 1, the 0 at 2, y-intercept at 2, and so this one's pretty clear, isn't it? That, and we know that at minus 1/2 3/2, which is right here, we have a hole. No maxes and mins by inspection. And what? It's concave up on minus infinity to 1 and concave down on 1 to infinity. All right, enjoy.